Hey Tube, welcome back. How does Google ensures that when you update data in Europe, the same update is instantly reflected in Asia? It's all about achieving strong consistency across their globally distributed systems. Okay, first let's answer the question of what is exactly a strong consistency. Strong consistency means that every read operation returns the latest write in a world where users and applications scan or span consistence. This is a game changer. Again, strong consistency basically means when we have like two nodes trying to read a piece of data, like three nodes, all these nodes will read the exact same thing at the exact same time. Again, strong consistency means that every read operation returns the latest write and returns the same write in a world where users and applications span continents. Like we have like one user in Asia, another one in Europe, another one in Africa. When they request a specific piece of data, they will read the exact same thing, and they will read the latest version of this data. But how does Google achieve this level of synchronization across its massive infrastructure? So let's become first about what causes a problem. When we have like our MySQL database and we have only one server and this server gets too much data, the solution is to partition this database. So we will partition the database into two partitions, for example, to make everything simple. So Google's distributed database is divided into partitions. We have, as you can see here. And these partitions are replicated across different geographical zones. A zone represents a physical data center in a specific location. Each partition has a leader and followers. The leader manages writes while followers handle reads. But how do they coordinate to avoid conflicts? Enter the Praxo or the Paxos consensus. This algorithm ensures all replicas agree on the same data. In this setup, the leader orchestrates the writes while the followers ensure data consistency. Paxos prevents conflicting updates, making sure that even if a server fails, the system remains consistent. Okay, let's understand the rule of true time because there's a catch. How do we ensure all servers around the world are in sync when time itself can vary, when time itself is not the same? Google's answer is the true time. A true time, a combination of GPS receivers and atomic clocks that synchronize the time in every data center with nanosecond level accuracy. Every server syncs its clock with true time every 30 seconds, ensuring consistent timestamp for operations. Okay, let's take an example to understand how does this work. Okay, so let's assume that we have a client. The client will request, the client request is sent to the nearest zone. Let's assume it's partition B, which is the follower, is not the leader. The follower, partition B, will ask the leader for the latest timestamp. The leader respond with the current timestamp. The follower ensures the data is up to date before responding to the client. If the follower's data is outdated, it waits for the leader synchronize before responding. Okay, but Why does this matter? This architecture ensures first, data consistency across continents, fault tolerance in case of failures, 3, seamless user experience no matter where they are. So, by combining Paxos for consensus and TrueTime for synchronization, Google achieves a level of strong consistency that powers its global services. This is how they keep the world connected, one synchronized endpoint at a time. That's it for this video, and I hope you enjoy my video.